So today I'm going to be talking about a return to work after COVID. And I know this may seem a bit preemptive, especially given some of the increased restrictions that have come in. I know in our province in Alberta, I know Ontario is going through similar things right now. And of course, none of us are really preparing to go back to work quite yet. But it never hurts to be prepared, and it's a good discussion to have now, so that when the time comes, we're ready to make that transition and have it be as seamless as possible. So there we go. Just a couple words about myself. So I'm an industrial hygienist. And in my previous life, as I like to say, I was working in the field of molecular microbiology. So essentially, I worked with human viruses over at the U of A. And when I left this field and got into industrial hygiene, I kind of left that life behind me a little bit. And the COVID situation has been quite interesting. Because it's kind of started to bridge that gap between my previous life as a microbiologist and my current career as a hygienist. So it's been an interesting year, to say the least. I mean, I don't like to say it's been enjoyable, but in a way it has been, just to try to troubleshoot some of these issues with our clients, and again, just to kind of reopen that interest that I always had about viruses and how they work and what they do and how they can make our lives miserable and better in some cases. But yeah, it continues to be an interesting year. So moving into industrial hygiene. So this is the question that I get so frequently from people who are, before, when we actually used to meet people out in the street. But what is an industrial hygienist? Some of you may know, others may not. But essentially, the simplest way to explain it is it's the science of occupational health and safety. So industrial hygienists use the scientific method, of course, research, observation, formation of hypothesis, testing with experiments, data analysis, and reporting of conclusions. We use that process to solve issues related to human health and occupational health and safety. So this requires a little bit of knowledge from a whole bunch of different scientific disciplines: chemistry, biology, physics, anatomy, math, physiology. A little bit of knowledge in all these areas makes a successful industrial hygienist. So it really is an interesting field. I mean, of course, I'm a little biased because I'm in the field, but it's a really interesting way to look at health and safety. And again, on the other side, it does incorporate a little bit of art into the science. It's not purely a science; it's also an art because of that human element. So we're obviously talking about human health and health and safety of people. So there is that human element involved with industrial hygiene that comes into the process of research and troubleshooting problems. And because of that, we need to be empathetic and creative when it comes to solutions. Because of course, everyone's a little bit different. Everyone's bodies function a little differently. And this is important information to have and to keep in mind when we are evaluating these problems as they relate to occupational health and safety. So jumping right into how to transition back to work after COVID. So it's a question that we as industrial hygienists are being asked and will continue to be asked, I hope, as buildings prepare to welcome back people and people prepare to go back into their offices and kind of, emerge from their homes after the hibernation. But Indoor air quality has always been an issue. So this isn't not a new thing. I mean, it's kind of trending now, but indoor air quality has always been an issue. I believe one of the previous speakers talked a little bit about sick building syndrome. And generally speaking, industrial hygienists hate this term because it's a very broad umbrella term. But, you know, Cole's Notes version, you experience symptoms Monday to Friday when you're at the office. You leave, you go home for the weekend, you no longer experience symptoms. Return to work on Monday, you experience symptoms again. Obviously, that's something related to the building. That would be considered a sick building syndrome situation. The causes of this could be innumerous. But again, that's why it's an umbrella term. It describes a huge number of different problems. But again, Cole's Notes, you're sick at work, not sick at home or away from the office. Allergies is also a big thing that's an issue in office environments. Many people have seasonal allergies. Many people have allergies to things in office environments. And sensitivities, it was mentioned in a previous presentation. Everyone's body is susceptible to different allergens and contaminants in different ways. So great example, you know, you're at the mall, there's a Lush store. Two people can walk into that store. One person will be completely overwhelmed by the smell and have to leave. Another person might be completely fine with it. So again, that's genetics. That's a different sensitivity to different smells, contaminants. There's not a whole lot we can do about that. That's just the way people are. People are different. But again, as hygienists and health and safety professionals, we have to be aware of those differences and make sure that any solutions that we come up with take those into consideration. And that's, of course, where that human element comes in. So up until now, I mean, many of the work we've done with indoor air quality pre-COVID has been complaint-based. So we don't get brought in to even evaluate the effectiveness of the controls or the HVAC system or even evaluate the indoor air quality until there's a complaint. So until you have that employee who's saying, I can't come to work because my allergies are so bad, no professional will be brought in. So again, that's a reactive approach. It's not proactive, which, as I'm sure we all are aware, is not the best approach to dealing with indoor air quality or really anything. But of course, we're talking about indoor air quality here. And it was mentioned before, 90% of our life is spent indoors. This is not something that has a minor effect on our quality of life. It has a huge effect on our quality of life. We spend time in our homes. We spend time in our offices, in stores. Most of our life is spent inside. So a focus on optimizing the indoor air quality and the air that we're breathing, of course, that should be a focus. It's very important. And part of the challenge of addressing that, or even bringing it to the forefront of knowledge, is this challenge of invisibility, which we deal with not only indoor air quality, but many different types of airborne contaminants that affect worker health. And what I mean by that is when people can't see something, they don't take it as seriously. If you walk onto a work site and see a huge tripping hazard, immediately you notice that is a hazard. Let's address that right now. Move it out of the way. When you walk onto a site and you can't see anything, or walk into an office, you can't see that there's an indoor air quality issue. So you don't even consider it a problem. That doesn't mean that it's any less of a problem. It's just not in your face. And this is something that we deal with all the time, is trying to even convince people that things they can't see can hurt them. And I think that COVID has actually gone a long way to addressing some of that, because of course we can't see COVID virus. But everyone is aware that it's around us and can make us sick, and even in some cases kill us. And other things, noise, lighting, location, all those things have an effect on indoor air quality. It's very situational dependent, and that's why the advice of a professional is really important when trying to address these issues, because it's not as simple as it may seem. the issues can be quite complex. And again, in this post-COVID world, we are seeing an increased awareness for airborne contaminants. Of course, most people are focused on COVID, but some of these other invisible contaminants, as well as just a general awareness of building ventilation and how this may improve or be to the detriment of human health, of the occupants of the building, and how it's not just something that you don't pay attention to, but it's something that you can address proactively and optimize in order to increase comfort, increase health, and just increase the general well-being of the people who are in the building. And when we talk about going back to work, there's so many concerns that most people have. And this is obviously not a comprehensive list. It's just some of the things that we hear most frequently as concerns when it comes to going back to quote unquote normal life and going back to office work. And we'd like to, again, try to simplify the solution as much as possible for the purposes of the transition back to work. And these two things, if we can just focus on these two things, it's going to go a very long way towards helping make the transition more seamless and making sure that people are more aware of what's going on in their buildings and thus feel a little bit more confident. So indoor air quality, of course, we'd like to take a proactive approach to that and optimize it. And then, of course, the follow-up to that is evaluating the efficacy of the controls that we have in place, which, of course, is just as important as the optimization, is doing that follow-up, making sure that the controls that we put in place are as effective as we'd like them to be. Okay, so viral transmission in the office environment. So how far will viral particles actually travel through the air? So the simplest answer to that is as long as forces acting on them keep them in the air. And what I mean by forces is a variety of things. So air current speed and direction, the droplet size. So again, we have those large respiratory droplets, the smaller droplets, aerosols. The speed of expulsion. So are we just talking or is it a very forceful sneeze? So one of the big and most important solutions to optimizing those forces to prevent the viral particles from staying in the air is sufficient and effective ventilation. So you can see from this diagram, which is of course very simplistic, but it gets the message across. In the upper picture, we have someone expelling respiratory droplets, which we presume contain infectious virus. And they remain in the air because the forces acting against them are essentially causing them to do that. So they just float around. And then, of course, other people who are nearby can inhale them. And that can cause, depending on how many viral particles are inhaled, again, we could go on about this, but generally speaking, we'll simplify it. The other person who inhales the respiratory droplets containing the infectious particles gets sick. So in the bottom picture, we have a very simple solution. Someone opened a window. And now we have different forces acting on the room. Now we have viral particles that are contained within these droplets moving in a different direction. And again, this is a very simplistic solution, but you can see now we've affected the forces in the room, and we're now reducing the risk to this person who is also in the room. Whoops, there you go. And this comes out of an ASHRAE publication. Again, it's pretty straightforward, and I'm sure most people are well aware of this, but increasing the air changes does decrease the risk generally when it comes to airborne contaminants such as COVID. And we want to be in this 4 to 6 air changes per hour range, and with an attention on the temperature and humidity, which is quite important. The virus likes dry conditions and will remain in the air longer in dry conditions. And ideal conditions, which is generally 40 to 60% humidity, the virus will be less likely to remain in the air, and thus the risk is a little bit lower for the building occupants. So just maintaining that comfort level with humidity within your buildings can go a long way towards actually reducing the risk to the occupants in terms of viral transmission. So again, we've heard a little bit about UV filtration. We all know what HEPA filters are. Recirculating air is generally not a great idea if you're trying to purify the air inside the office environment or industrial environment or whatnot. But if it has to be recirculated, the air coming back into the space should be filtered. And again, there's several different ways to do this. But the takeaway here is that we want to bring as much fresh, clean air into the space as possible and minimize the amount of air that is recirculated without filtration. ASHRAE is recommending at least a MERV 13 or higher in commercial buildings. And the vast majority of commercial buildings do not have this amount of filtration in their HVAC systems. So this simple change, again, goes a long way towards filtering that recirculated air if there is a significant amount of recirculated air, and can thus, of course, make the air that's going back into the buildings cleaner and safer for the occupants to breathe. And most simplistic solution of all, reduction of building occupancy. So the fewer people you have in the building, the fewer people you have exhaling. It's less taxing on the HVAC system and the filtration systems if you have them. And of course, there'll be physically distanced, but again, we know that that's not always the be all end all of controls. But as we start bringing people back into offices, having a stepwise approach, which doesn't just pour everyone back in at once, is going to be effective at making sure we can monitor and control the efficacy of the controls as people re-enter the building. So keeping the occupancy lower than it was pre-COVID, or lower, of course, than the maximum number of occupants that the building allows, is a really good idea in this return to work situation. So obviously this is a talk about indoor air quality, but I couldn't help but comment about surfaces, because it's something that we get asked quite frequently, and it's a real concern of many people when going back to work, and even just being in the public. And that's infectious surfaces. So if you've heard this term before, fomites, that's essentially the scientific word for an infected surface. So a surface that has infectious particles on it, we're talking about COVID viral particles specifically, that would be called a fomite. So all the things in these pictures are example of fomites. So you've likely heard that, yes, the COVID virus has been detected on a variety of different surfaces: plastic, stainless steel, paper, cardboard, etc., ranging over periods from hours to days, depending on the surface in question. So you would assume that this means that there was a high risk associated with fomite transition. Not the case, and the reason is these results represent lab conditions, which are idealized. So first, they use an enormous amount of virus to start these experiments. So you can see in this really simplistic diagram, on the left-hand side, we have a lot of virus, which of course, in turn, is associated with a high chance of infection. And then on the right-hand side, little virus, a lot lower chance of infection through this fomite. And we have perfect conditions in labs. So this can be anything from the temperature, the humidity, the growth medium. All these things contribute to how successful the virus is at remaining infectious on the surface. So again, just because it can be detected after 3 hours on plastic, now I'm just pulling this out of the ether, don't quote me on that. doesn't mean that that's what's going to happen in real life. And if you look at real life, the evidence just isn't there to support fomates playing a big role in transmission of COVID. There's very limited studies showing this happening in the real world. And that's because of variation in temperature, in UV radiation, in humidity. The real world is not a lab, and we can't necessarily take those lab conclusions and apply them directly to the real world. Therefore, the evidence isn't there to support fomites being a high risk factor in COVID transmission. In fact, it seems to indicate, the data seems to indicate that it's not. That doesn't mean there's no risk. It just means that it's very low. So even things with very low risk we can still address, and not to say that cleaning, disinfection of high touch point surfaces, these are great things that you should be doing in your buildings. Again, COVID is not the only thing that we can catch, and it's not even the most harmful thing that we can transmit between fomites, between respiratory droplets. There are so many different viruses, bacteria, fungi, parasites. You would be horrified to know some of the things that have probably been on surfaces prior to COVID. And I will say that now our world is probably cleaner than it ever has been. We've certainly seen this with a lot of the buildings that we've assessed. They're so clean right now because of the cleaning protocols, and that's a good thing. That should continue. Even in a post-COVID world, cleaning is something that should happen when people gather in public spaces. And just because we have this minimal risk of fomate transition for COVID does not mean that we should not be cleaning, doesn't mean we shouldn't be washing hands and sanitizing. Of course we should be, but hopefully that information is a little reassuring, at least, when we're going out in public and touching things like shopping carts, for example, is a big one. Just keep in mind that if you're cleaning and sanitizing, the risk of you contacting COVID from one of those surfaces is extremely low. So what can we do? The big three, of course: wash, sanitize hands, don't touch your face, wear a mask. I've heard this a million times. I'm just reiterating that it's no less important now than it was at the beginning. And even more importantly, in my opinion, is if you're sick, stay home. This applies to forever. Always in life, if you are sick, stay home. Lots of things are communicable, and that's why we have sick time. That's why, we have this time to rest and recover, and come back to work when we are feeling better. So even past COVID, 5-10 years down the road, if you're sick, don't go to work. And the most importantly, be aware, use your critical thinking skills. The fear mongering and the clickbait headlines and the social media headlines throughout this whole pandemic have caused so much damage. And now we're seeing some of the results of this in the vaccine hesitancy, and some of the protests that are going on. Use your critical thinking and listen to the experts. That is the most important takeaway. If you remember anything from this whole talk, remember that. That's my PSA for the evening. Be aware, use your critical thinking skills, use your common sense, and listen to the experts.